Good evening, everyone. As Ben said, I'm Matthew Cornford. I'm a head of product at Ocado Technology, looking after an area we call handling robotics. And today I'm going to talk to you about how we use Java at Ocado Technology to orchestrate robot swarms. So if you don't know who we are at Ocado, then we are a technology company who are trying to transform online grocery through cutting edge technology and serial innovation. In the UK, we have an online grocery retail business, Ocado.com, but in recent years, we've been moving to power grocery businesses all around the world with our kind of advanced robotics and leading a grocery e-commerce solution. So we've been using Java at Ocado Technology for quite a few years now, at least 10 as long as I can remember. And we use it across the whole of what we call the Ocado Smart Platform. This is an end-to-end grocery e-commerce platform for global grocery retailers to take their businesses online. And so we offer everything from web shop, mobile apps, supplier chain systems, advanced automated warehouses, on-the-road driver and delivery software, all for our kind of partner businesses around the world, like I say, to deliver the best service to consumers and get their groceries online. My experience comes from working in our automated robotics space, and that's what I'm going to talk to you today about, how we use Java there. So to give you a flavor of our solution and what our robotics looks like, I've got a short video which I want to show you. And so this is the robotic solution that I have the luxury and pleasure to work with every day. And we believe this is the most automated warehouse in the world. Everything you can see in this video is developed in-house at Ocado Technology. And I'm going to talk to you for a couple of examples here of how we use Java. One about how we use Java in the development of the onboard robotic control software. And one about how we use Java in our air traffic control like overarching software, which is controlling this whole swarm of robots. So our system can support many thousands of robots roaming at any one time, communicating with all those many thousand robots in real time, issuing them instructions in real time. So we have some really genuinely interesting and complicated challenges in the software we're developing. So I've got three main sections I'm going to talk to today. I'm going to start with actually why Java. Java is not always necessarily the most obvious language to be using in this space. I'm going to talk about why we use Java. I'm going to talk about a few of the optimizations we use when developing our kind of air traffic control style control system. And then finally, I'm going to use an example of how we actually test the embedded robotic software with using Java as well. So why do we use Java at all? Well, I've got this slide in because anyone who kind of if I get into more details about this software, people always ask us, why are you not using software like C, C++, more recently, why are you not using Rust? And these are valid questions about why we might not be using those languages instead of Java. But obviously it's a trade-off for us. And what we're trading off is the difference between performance and how quickly our developers can actually develop. We are working in an agile environment. We are working in a very complex environment. And so having our developers be able to work fast is really important for us. And we feel that Java gives us the best balance between a performance system and one that allows our developers to go fast. Some other reasons about why we use Java. I mean, it's an evolving platform. That has been highlighted even more recently with the 6 monthly releases of Java in the last few years. You know, the platform is rapidly evolving. Every 6 months, new features are getting into the hands of developers. The Java and the JVM is generally just getting better, more performant. And so we're able to leverage that evolving platform to our benefit. And I've got an example later about where we've done that. And lastly, actually, by using Java, it gives us access to a global talent pool. Java is always listed in whatever ranking you look at as one of the top programming languages in the world, which means for a growing business like ours, by using Java means we can get access to a lot of great talent across the world. So when we think about all these things, rather than just necessarily the technical details or the technical aspects of a language, this often leads us to continue to choose Java as our language of choice, both, like I say, in the automated robotic space, but also across our whole platform. So if I move on to talking about some of the optimizations we make in our control system software, I'm going to focus on two today. I've only got about 20 minutes. I'm going to give you an example from some event scheduling optimizations that we've done and some garbage collection optimizations that we've done in our control system. So event scheduling, like I sort of tried to describe when I showed the video, we have a piece of software which we liken to an air traffic control system. This is sitting over the entire grid, and it's commanding, like I say, multiple thousands of robots all at once, communicating with each of them 10 times a second, and then so processing tens of, if not hundreds of thousands of events every second, and having to issue commands back to those robots in real time to keep them moving. And so we have quite a need for quite a performant event scheduler. It needs to allow us to schedule events for very specific times in the future. We need to ensure that any individual event we schedule in the future will actually be run at the time we want it to be run. It can't be delayed for any arbitrary reason. And we also can't allow those events to back up, because what happens if events back up or if events are delayed, then the system basically stops. We need to keep those robots continually working to keep the throughput of the system very high. So if you're an old school developer, you might kind of turn to a class like timer in Java. Hopefully, kind of that is well too old that no one turns to that anymore. Another kind of obvious choice in the Java kind of JVM libraries is a scheduled thread pool executor. This definitely meets the need, our first requirement of being able to schedule events for a particular time in the future. But actually, as I'll describe now, it doesn't actually meet some of the other some of the other requirements. When you go and schedule an event, kind of, you don't really necessarily, unless you read the documentation, know what's going to happen when that event comes to be scheduled. But if you dive into the source code of this class, what you'll find is that actually, depending on how you set up this class, when a new event is going to be scheduled, going to be executed, it might decide actually to create a new thread. Now that's quite bad for us, because a thread can take quite a bit of time to be created. And so that sort of breaks our requirement of any single event kind of not being arbitrarily delayed. If we have an event and the executor just decides it wants to create a thread, well, that will delay our event being scheduled and kind of may mean a loss in performance from our system. What you also see if you look into this class is that it has an unbounded queue of events. So again, if things start running a bit slow, then that unbounded queue will just continue to grow and grow and grow, and events will back up. And again, that's not something we want to happen. We need our events to be processed on time and not being backed up. So what did we do to address these problems when we can't find a solution within the standard Java toolkit? Well, we wrote our own. So talked about why that class doesn't meet those requirements. And what we created is what's known as a busy loop. And so this is some sort of very simplified code of what our event schedule looks like and what the busy loop looks like. So I'll start from the top. We have a queue. That is a queue of events. And then we have a while true loop. So this is a loop which is going to continue forever. And basically it's continually looking at whether there is an event to run, if it's the right time to run that event, and if it is, then it will run it. So this is great, but it has some pros and cons. I mean, if you Google busy loop on the internet, actually a lot of sites and a lot of advice will be not to use it, and in most cases that's true. But in our case, with our quite tight requirements, it meant we were actually able to get our latency for events being processed from about 5 milliseconds down to effectively 0. Like I said, because that time of that loop going round and round and round, as soon as that event is ready to process, we will run it. We also saw that actually because of that, we could get 3 times higher throughput of events through our busy loop than we could in our system using a scheduled thread call executor. So this was great for us, and I think it's a prime example of some optimization we had to perform in such a kind of strict environment and with strict requirements. What are some of the disadvantages of actually doing this? Well, you use 100% of a single CPU or a single thread. So, you have to be willing to dedicate a whole CPU to that loop. This is one of the reasons why you get a lot of advice not to use it, because there's a lot of wasted CPU time where events are being processed and you are just spinning through this loop. But for us, that was a cost we were willing to pay. And an interesting side effect is that actually by running 100% CPU constantly for a prolonged period of time, you can actually reduce the clock speed over time, which was an interesting aside. So that's something we monitor and look at as well. So that's one area where we have kind of performed some optimization in our system, where the standard sort of Java libraries didn't provide us a solution for what we needed. Another area where we spend a lot of our focus in this system is garbage collection. Again, kind of as I said before, we really don't want events to be paused or delayed in running. And garbage collection, unfortunately, is a primary source of pauses in our application. And so if we don't get our garbage collection under control, well, it could wreak havoc in our control system, and the whole kind of the whole robotic system you saw can come to a halt. And so we spend a lot of time profiling our system and making sure garbage collection isn't having too much of an impact. So I've got some examples here of some things we've done to reduce the impact of garbage collection. These aren't things I would necessarily recommending as standard advice, but these are the sorts of things that when you're really having to optimize quite finely your system that we've done. And so if you think garbage collection is all about object creation and freeing those objects once you finish with them, a lot of these tips basically come down to using less objects or stop using objects at all. So we don't use optionals in APIs which are heavily used. Optional is an unnecessary extra object, and any APIs that are being hit at higher frequency, well, we don't use them there. That it removes an object and hence removes some pressure on the garbage collector. We use for loops instead of streams API, again, only in those places where your profiling shows kind of really hot spots in your application runtime. The streams API is great for readability, and I would recommend it 99% of times. But kind of from when you profile and test, if you find examples where kind of the, say, hotspots and the garbage collectors being hit hard, then you can reduce some of that object creation by moving to for loops. Similar, let's say these are all tips on a similar theme, using array-backed data structures instead of kind of object-based data structures like hash set or linked list. And an interesting we found is actually avoiding boxing and unboxing, especially in places where you might not expect it. So log lines in particular can be a nasty culprit for that. But like I said, these are not things I would recommend you do just litter throughout your code. These are tips that we've done, like I say, from extensive profiling and that we do in the right places. Some other tips when dealing with garbage collection, enable your garbage collection logs by default. They're cheap to collect, but very handy after the fact. And understand the different garbage collectors that Java offers. I'm going to talk about 2 different ones in a minute, and you'll see why it's important to understand the difference. And yeah, don't just take the latest and greatest garbage collector, because actually what we found in our profiling is sometimes the older garbage collectors can be better depending on the style of application you're developing. So I want to talk about 2 of the more modern garbage collectors now briefly, G1GC and ZGC. G1GC was released, if I remember rightly, in Java 7 and became default in Java 8 or 9. And ZGC was experimental from Java 11, and I think it's just been made non-experimental in Java 15. And why these are of interest to us is that they promise low pause times. So G1 GC, you can control how long the pause is, which for us in a real-time system is really important. Being able to have that control of setting or indicating the maximum time we want our application to pause is powerful for us. And obviously everything comes with a trade-off. So that trade-off in control comes in by kind of higher use of CPU by the garbage collector as it's doing work while your application is running. ZGC, on the other hand, promises even lower pause times than G1 GC can, kind of down to 10 milliseconds. So for us, that was extremely exciting when it first came out to try it. And we did some tests to compare these two garbage collectors. And this is, again, just highlights why we use Java, because what we see here is how we were able to gain quite a significant benefit in our system by us being on an evolving platform. We didn't have to do any work to develop these garbage collectors. We got them for free, but we were able to make them kind of utilize the hard work that's been put in by the Java and JVM developers. And so what this is basically saying is this: the percentile of pause times. Lines higher up the graph are bad and lines lower down the graph are good, and basically just showing that a large percentage of the ZGC pause times were a lot shorter than that of G1 GC, which was great for us. This is the same data presented in an equivalent graph. This is showing how much of runtime in a test is being taken by the application. So G1 GC, the application was running for 98.94% of the time. So that means for 1.06% of the time, the garbage collector was running and our application was not. And when we looked at ZGC, that went all the way up to our application running for 99.82% of the time. So that's something like a 5 times reduction in pause times, which is incredible for us. So for the last few minutes, I want to talk about actually a slightly different example where we use Java. And this is testing the embedded software which runs on the robots themselves. So the problem we're trying to solve here is our embedded software is written in C and C++. And if you've ever developed in those languages, historically, they've been quite costly and slow to test. Tooling got better these days, but I'm not sure if it's quite again up to the level it is in Java. We promote agile development and continuous delivery across a whole of Ocado technology. We want our C and C++ developers to kind of have that same mindset and be able to practice those same practices as our Java developers. And like I said, we're always trying to optimize for the speed of our developers. Being able to have them run their tests quickly and get fast feedback is really important when you're developing. And yeah, like I say, we want all our developers to have access to the same sorts of tools. So what this meant was that what we're doing is we are testing our C and C++ embedded code using Java. We have an integrated test environment where the 3 languages run together. We're using Java to kind of mock out hardware APIs. We're also using Java to write the actual tests. And then everything is packaged up and run in the JVM. So that means the C and C++ code is being kind of called, loaded in the JVM and run within the JVM. So kind of an interesting snippet of how you do this. If you've ever done this before, you might know that any header file that you have in your C or C++ code, you need to translate to a class file for the integration to work. When you have one class file, well, that's quite easy for a developer to do and keep that maintained, or even write the class file respective to the header file. You have several header files, then obviously you need to replicate that into several class files. Again, quite easy for a developer to maintain or to write a handful of classes and duplicate that. But what do you do in the case of our system, where we are testing a big library of embedded software, which has hundreds, if not thousands, of header files? we really want our developers maintaining and writing the equivalent number of class files. Hopefully, I've stressed so far that we are always focusing on the speed of our development, and so the answer is no. We don't want developers doing this. It turns out, if you're interested, there are some really cool open source tools out there that can automate a lot of this boilerplate code for you. So a tool called JNA and BridgeJ are two open source libraries which you can go and Google, which kind of help us to kind of link the Java and C++ code together and free our developers from having to think about that and actually let them think about writing tests and testing their software. So I just want to finish this section by talking about some of the challenges you get when you integrate Java and C into the same runtime. Well, garbage collection is limited to your Java code. The GC can't look into your C or C++ code and start freeing memory. That's not how it works. And so you have to make sure your C code doesn't blow up, doesn't leak any memory. Yeah, so that's one challenge. You have to kind of think very carefully about how your C code is going to run. C code can actually pass back bad objects, so objects which are like untype safe. So maybe it might pass back an array of the wrong length. If you've ever programmed in C or C++, or C in particular, you don't get that luxury of knowing you have to maintain the length of your arrays by hand. And so it's quite legitimate for your C code to easily kind of pass back a bad object and it just crash the JVM altogether. You don't get a nice exception, you just get a nasty kind of stack trace and the JVM blows up. Testing asserts in C code is quite tricky. Again, we obviously in our test code, we want our code to test edge cases as well. That sometimes means actively wanting to hit asserts. Again, you don't get nice exceptions when you hit an assert. An assert normally just blows up your C code and in turn blows up your JVM. And so we had to work around introducing some kind of intermediary layers to catch those asserts so that we can carry on running our JVM and test all those edge cases. And one of the last challenges we've had was around JVM startup time. So when you're running hundreds or thousands of tests, depending on what unit test framework you're using, sometimes that means the JVM starting up many, many times and actually loading a DLL, loading some C code, and even just kind of loading the JVM itself can be costly and lead to quite long running tests. So we became very sensitive to tuning our tests and our setup to make sure that JVM start time was as small as possible. Again, because we're interested in kind of that feedback loop for our developers to make sure they can get their test run as quickly as possible and their speed of development is quick. So to summarize, we love Java at Ocado Technology. We use it across the whole platform, and like I say, it provides us with many benefits, as I've one example shown, kind of ever increasing performance as well that we can sort of get from free from the JVM. We write our highly performant, low latent control systems for our robotic warehouses is in Java. And like I say, we also use Java in a more maybe unusual scenario to test our embedded C software. So that was a bit of a whistle-stop tour. Thank you for listening. I hope you found that interesting. And yeah, if you're interested in looking for a job, we are hiring. Thank you very much.
Thank you. Can you hear me?
Yep.
Yeah, Matt, thank you. That was great. Appreciate it.
You're welcome.
So there are a few questions. I'll start with someone who just identifies as C. So hi Matt. How do you prioritize what the team needs to be working on at any given time?
Yep. So that's not really a Java related question. At Ocado, we have a large army, I suppose, of product managers, and we use product management and that craft and expertise to help us do prioritization. So we kind of follow an empowered autonomous team model. Every team engineering team will have an engineering team leader and a respective product manager. And it is between the team lead and the product manager to understand their product, understand what need their product serves and what needs it needs to serve in the future, and hence make sure the right work is being prioritized at the right time. So yeah, like I said, I'm a product manager myself, so I spent a large part of my career as an engineer, moved over to product management recently, because actually prioritization and making sure we work on the right stuff is really important. I think really important to me and really important in general.
Cool, thank you. So next question is from Corinro. He actually, I know him quite well. We've met a few times. Yeah. So can you see that, or do you need me to?
I can see that. Yeah, I can read that. Yes. So we don't run Java on the robots themselves. Like I say, it's in the embedded C software which runs on the robots themselves. We use Java in our development environment to help test that software. The air traffic control software I was talking about earlier, that is a server process that runs on a server in the data center. And that will talk over actually a proprietary wireless protocol that we developed in Ocado technology based on kind of 4G technology. That's how it communicates with each robot kind of 10 times a second. So like I say, in our warehouses where there are over 1,000 robots, that's kind of over 10,000 messages a second being sent out to all the robots by that server process.
Great. He's also caveated that by saying great talk as well in the comment section.
Thank you very much.
This is the last question we've got, as you can see from Channa.
Yeah. So that's a really good question. I have a much longer version of this talk where I talk about how we do use simulation very heavily in Ocado technology to test both our embedded software and also our air traffic control light control system. So simulation is a key part of how we develop at Ocado technology. Unfortunately, kind of 20 minutes didn't really give me the time to talk about that much. But yeah, we always want to test in the cheapest way possible, right? So kind of following the testing pyramid, and simulation allows us to get much better test coverage in the office before we start to put our code and test onto real robots and test it against real hardware. You know, you want to be absolutely sure, even in our lab, we want to be sure that the software we kind of deploy onto real hardware isn't going to break it, right? We have different phases of testing, obviously unit testing, component testing, scenario testing, kind of full system simulation testing. And, you know, we try and do as much as possible in the office before we actually then go and run real robots in one of our test labs. And then before we get on to deploying into our actual warehouses, running and controlling real hardware.
Thank you. Yeah, just seeing if there's any more. No, that's it. So yeah, thank you very much. Thanks.
Pleasure. Thank you for having me, Ben. Kind of enjoyed talking this evening. Cheers.
Just before you go, is there any, like, if anyone thinks of anything they want to ask you or connect with you, is there any way they can?
Yeah, you can find me on Twitter at Bofalot, BOFALOT. Find me on LinkedIn, just Matthew Cornford on LinkedIn. Yeah, so happy to connect on Twitter.